let's take a look at tables. The first question I have I think I put like 6. If y'all get tired of doing them, if you're figuring it out, just tell me, we can move on. I did a bunch just in case you struggled on the tables. The first thing I want to determine is, one, is it exponential or logarithm? Because you can probably eliminate 2 answer choices and make the problem become 50-50. 50% of getting it right on a pure guess is better than 25%. So first we're going to determine that. Just, is it logarithmic? Is it exponential? And then we're going to do the harder part, which is let's write an equation without it. Okay? So first, what type of data is this as you look at this table? Exponential or logarithmic? How did you know? This is logarithmic because the x's are multiplying and the y's are adding. Here's what we're going to do. On the adding side, we're going to write that down first just because it's the easiest. How much are we adding by each time here? 6. Great news for you. If you're adding on the y side, that is always your a when it comes to writing the equation. I'm going to go ahead and just put that there. That is your a. If, hear me, if it's on the y's. It's not true if it's on the x's. If it's on the y's, that's a true statement. That is your y's. Your a's, I'm sorry. Excuse me. Your a's. X column. What are we multiplying by every time? 3. Now, if it was hard to tell, I would do a change of x to figure out exactly what we're multiplying. But there's no transformations. What are we multiplying by each time? 3. The value you're multiplying is what we call the base. And so here I'm going to write base once, but the variable we say is 3. I already wrote this once today, but I put this here just to help you in a second for solving these. So now let's do the harder part. Question 2. What equation would fit the data? Now you told me it's a logarithmic function, correct? For a logarithmic function, they use the letter f of x. F of x is going to follow this model. It'll be a log base parentheses x minus h plus k. That's as complex as we're going to get right there. That's your general form. As complex as we'll get, or as you want to get, will be right there. Now, what values from this equation have we already solved for?
A and B.
A and B. So I wish I had a little bit more space, but I'll fit it in. Here's what we already know is true. We know A is 6. Our B is 3. That's what we know. And I'm going to stop there. That's what we know so far. So how can you get the rest? Well, we start plugging in numbers and seeing if it follows this, because if it excuse me, I'm circling the wrong one. We're going to see if it follows this pattern, because if it does, we don't have any transformations. Remember, this is the pattern if there's no transformations. So let's plug in the first value. I'm going to plug in a 0. I think it's the easiest. If I plug in a 0 here, what's my base on our actual problem? So let's try plugging in, it's 3. If I plug in the value 0, 1, what I'm saying is, in this case, x becomes the n. Let's say n equals 0. I'm sorry, y. The y is the n. So I'm plugging in 0 here. Am I doing this right? For this point here, if I plug in a 0, yeah, that goes to 0 there. Okay, we're going to check to see if it matches up this point. So I plug in n of 0. What do you get if you plug in a 0 there? What's 3 to the 0?
3.
No, 3 to 0 is not 3, it's 1. Now, does that match up with our table? This is a good thing. That means there's no other transformations. Let's check it again. What if I did it one more time? Let's say now n is 1. I'm just picking a number. It doesn't have to be the number on the table. I'm looking, 1 might not. Yeah, 1 will work. Let's say we plug in a 1. So now my base is 3, and we're going to plug in a 1. So plugging in a 1, that means 3 to the first. I'm plugging in n of 1. 1 there. Okay, what's 3 to the first? 3, and well, 1's just 1. Does that match up? Do I have a 0.31? No, because why not? it comes down to this A right here. You see how that doesn't match up perfectly? Because there is one transformation. What are we supposed to be doing with A? Multiplying by 6. And so this actually does work perfect. If you took your 6 and multiplied these, if you're like, oh, okay, now that I'm getting this, what this means is I have an A that's multiplying the Y values. What happens is this needs to be multiplied by A, which is 6, and this needs to be multiplied by A. If you came back, you'd realize what's 6 times 0? 0. So it'll still work. What's 6 times 1? 6. And so it would work. This is right. Another way you could do this is just by plugging in a number over here and checking. Okay. So for example, I'm going to put a minus h plus k here, minus h plus k. You could plug in numbers and start seeing if it works. If I plug in a 1, basically you're saying 3. I'm getting how am I? Okay, it doesn't have any transformations. Let me go to one that does have transformations and you'll see how it works, okay? I'm getting lost on how to explain this. This doesn't have any transformations other than that 6 right there. We'll see it in a moment where they do, though. Getting lost in my head how to explain that this doesn't have transformations. Let me show you one that does have transformations. It'll make more sense. Okay, let's go to the next problem. I told you got like 6, so I got plenty here to look at. Don't quit if you get confused on number 1. This time, what function are we looking at here? Exponential. This is exponential. That's the first part. If you can get that, your problem's 50-50. How did we know it was exponential? X's are adding. How much are they adding by? Now, that is not necessarily going to be equal to A. Our A might be 1, but it does not have to be 1. Because A is a vertical translation. A vertical dilation, I should say. Vertical dilation. This right now is telling me about my horizontal dilation. No, A is always from the Y values. Always, always, always. Y goes, yep, because A is on the outside. Okay, so when we rewrite the equation, here's what the equation should look like. So they call this one g of x. Here's the standard form for an exponential. It's going to be A times B. You don't have to put the parentheses there, sorry. A times B, and let's do the parentheses here. X minus H plus K. Okay, let's start solving. Let's get our base first. We don't know what our base is yet. Can you tell readily, like, is this one, is it easy to tell what we're multiplying by? No. I can tell it's changing crazy, so it must be multiplying. What I'm going to do is create a new table, and I'm just going to call it change of y. I'm going to call it a rock, even though this one would be a rock. I'm just going to call it change of y, so that when I do the x, it'll look the same on each problem. Okay, what are we changing going from 4 to 5? 1. How much do we change from 5 to 7? 2. How much from 7 to 11? And then how much from 11 to 19? Okay, the change in y column, you can also get your base from there. It'll still be the same base, even though we've changed our numbers. If you do the change of column, this will always give you a perfect multiplication if it's exponential or logarithm. It doesn't change the values, but it will show you what's happening. What is our base this time? Now it's easier to tell. What are we actually multiplying by? 2. We're multiplying by 2. Did I do it as an x times? Yes, I did. Okay, x times 2, x times 2, x times 2. That is my, what letter would that be? Nope, not A. That's our base. The one that's multiplying is your base. Our base equals 2. Now, from the change of column, you can tell if there's been any vertical translations. Now, how can I tell this? If you have a vertical translation and your A is 1, let me say this. You can tell if A is 1 or not 1 by if these are all off by the same amount of numbers. You see, what's the difference between 4 and 1? 3. What about here? 3. What about here? What about here? So these values are not getting multiplied by anything, but they are getting added by 3. You have to add them. You have to add 3. And I'm going to check real quick to make sure I'm not telling you that it's not going to become a -3. Let me check real quick. Where's my table here? 0, 4. Yeah, we have to add 3 over here to get this column. So I'm going to do like a +3. What does that mean? When I write my equation, what I just determined is because I have to add 3 to this column to make it be this column here, this is a +3. So here's what we now have. We have g of x equals a, and we know our a is actually 1 since there's no multiplier, since these are say the same amount off. Let me say here, I'll put the note, a is 1. A equals 1 since g of x equals change of y plus 3 without a multiplier. And that's why a equals 1. So my a is 1, so I don't even have to include in the equation. What's our base? 2 power x minus h plus, which is 3. Okay, last thing. Let's plug in a point to see what h is. If you start plugging in points, you know what? I wanted to show you. This is a way with property. There's property. I hate it when I do this, but I'm going to change in the middle. The easier way of even solving this is your h. Do you remember your exponential properties? I'm going out of order. I told you I was going to do this at the end. That we have what's called the quotient property, which said if you're subtracting here, do you remember that a horizontal translation can become a vertical dilation? Do y'all remember that lesson? We talked about that. I'm going out of order here. You can actually solve this for a without even using an h, which is probably the easier way of doing this. I'm going to scratch because all of a sudden I'm thinking about this. This will be the easier. I should have taught it this way from the start of class. Here's the way we're going to solve this is I'm going to ignore the h on exponentials and do it this way. I'm going to do b to the power of x plus k. Now, why do I say that? Because this will be much easier for you to solve. What I can do is I've already solved for the base, and I'm just going to stop and act like I've only solved for the base. Okay, we're going to plug in 2 values, and I'll show you how this will work. I want to plug in 0 and 4. 0 is my x, 4 is my g of x. So just start this problem fresh right here. What I'm going to do is g of x is 4. You see how g of x is 4? Make sure everybody's tracking. And I want to pretend like I don't know a. I'm going to pretend like I haven't found that. Let's say a. We do know our base. What's our base? Just put a 2 there. We do know base outright, so I'll put a 2 there. So it'll be a times 2 to the, okay, in this problem, what's our x value? If g of x is 4, what's our x? 0 plus k. And now I will simplify this. What is 2 to the 0 power? 1. So I have 1a plus k. And I'm going to stop for a second. And now I'm going to do this again. I'm going to plug in a different point. Let's now plug in 1, 5. 5 goes into g of x. So I'm going to say 5 equals a times 2 to the, now what's my x this time? 1 plus k. And we'll simplify that. I have 5 equals, what's a times 2? 2a plus k. I could use these 2 equations together to solve my problem. I'm just going to subtract these 2 equations. I'm going to take this one because it's a bigger number. I like dealing with positives. And I'm going to say 5 equals 2a plus k. And what I'm going to do is subtract the other equation. 4 equals a plus k. Now, before I tell you why, I want you, don't say it out loud, give everybody a chance to think. I want you to think, why did I decide to subtract these two equations. Look over here and hopefully you'll figure out, why am I subtracting the two equations? Give you a second to think. Yeah. Okay, what do y'all think? Why did I choose to subtract them? Because the variable k will disappear. And so what's left over? What's 5 minus 4? 1. What's 2a minus a? A is 1. And so now we have that variable. And now that I have that variable, I can just plug that into either equation. Since I have this one right here, we'll plug that in. And so now we'll say, instead of 5 equals 2a plus k, I'm just going to say 5 equals 2 times 1 plus k. What's 5 times 2 plus k? 5 equals 2 plus k. I said that wrong. 5 equals 2 plus k. What is k going to be? That's correct. When we subtract 2, we find out k is 3. Now that is probably that's the better way of teaching you, so you're not guessing from all this table stuff I was starting to do there. So I'm going to take this away so you're not confused by it if you look at this later on. I'm just going to leave it like that. There's your algebra. I'm going to take that away, change this equation. So that's how you can solve that. You don't have to do the minus h, because a horizontal translation is the same thing as a vertical dilation. That was a property we learned on the exponential function manipulation. I think that was lesson 2.6. All right, I'm going to do another one. I told you I got a bunch. I don't want to confuse you, so I'd rather you see it a bunch of times rather than be confused one time. This time, first off, let's make it where you're 50-50. Where worst case scenario, you're making a 50 on the test rather than a 25 on the test, going off pure statistics. What type of function would you say this is? Exponential. I hear exponential. Why exponential? Because the x's are adding. X's are adding, and what's happening with y's? Is it a consistent change? No, it looks weird. So put a b to the power of x plus k. That's going to be our formula right there. All right, let's start filling in. This is changing my ones. Will that be my A? I'm going to say this a bunch of times. Is that necessarily my A? No, because it's the X column. A doesn't deal with the X column. What column does A deal with? The Y's. So that's not A. Can we tell right away what this is being multiplied by? Is it easy to tell or not so easy to tell? Not so easy. Let's add a column. What should we call this column? Let's do change of y's. Let's do a change of y column. Okay, how much do I change going from negative 0.5 to 0.5? We increase by 1. What about from 0.5 to 3.5? We increase by 3. What about from 3.5 to 12.5? Increase by 9. What about 12.5 to 39.5? 27. Okay, this cleans up our data. Now we can see, what is it that we're actually multiplying by? 3. We're multiplying by 3. So what does that tell us? The base, not the A. That tells us our base. So our B value equals 3. Now what I'm going to do is just plug these in, and we're going to solve our equation. So now we know g of x equals, do we know A? Do we know B? B is 3 to the power of X plus K. So how can I solve from here? We can plug in some points. Which point do y'all want to plug in first? Do you want to do this one or ignore that, the negative, and go to the next one? What do you want to do? Start with 3? Deal with positives? Okay, the 0.5, what is that value? The y. So 0.5 equals a times 3 to the third power plus k. So let's simplify. What's 3 to the third? That's 3 times 3 times 3. 27. That will be 0.5 equals 27a plus k. Okay, now what did we do last problem after we did that? We did a second point. Which point do y'all want to use this time? Do you want to use 4? That's going to be getting us a pretty big number there because 3 to the fourth. We want to use squared. Let's say we're not scared of the negative. Let's go with that. We're not scared of the negative. Let's do the negative. If we did plug in negative 0.5 equals a times, I put a 2 there, sorry. Base is 3 squared plus k. I plugged in a 2 for x and a negative 0.5 for g of x. Let's simplify that. What is 3 squared? So we have negative 0.5x, negative 0.5 plus 9a plus k. Okay, do you remember what we did from here? Let's subtract the two equations. I'll just list this one first because I see the a's are bigger. I think it'll be better to do it that way. So I'll take the 0.5 equals 27a plus k. And we are going to subtract negative 0.5, no, not close parentheses, sorry, equals 9a plus k. Now, before you call it out again, I'm going to let you take a second to look at it. Why is it that I'm subtracting the equation? What does that benefit us, subtracting that equation? It eliminates the k. I didn't mean to do that. This is a negative of a negative. So what do I do with that 0.5? Add it. What's 0.5 plus another 0.5? 27 minus 9. 27a minus 9a's. 18a. And so what does a actually equal here? One over 18. I agree with you. A is 1. Whoops. A is 1 over 18. And so now I can choose any equation. Let's just use this one. Negative 0.5 would equal 9 times 1 over 18 plus k. What is 9 times 1 over 18? Or what is 9/18ths? 1/2. So negative 0.5 equals 0.5. I'm changing to a decimal. Plus k. How would I solve that? Subtract 0.5. It'd be subtraction since they're adding together. And we now will get our k value. What's negative half minus another negative half? Negative 1 equals k. And so we have all of our answers. Let's go ahead and write our final equation. G of x would equal 1 over 18 times 3 to the power of x minus 1. There's your equation. Now, I said it earlier. I have a whole bunch. Just tell me if you're like, hey, I got it down. Just tell me if you come to that point. Hopefully, you're seeing the strategy here. I'll tell you this, you don't have to write that many equations. Don't just be thinking, oh my goodness, how many times are we gonna have to do this in the test? You don't have to do this that many times. I'm just getting the skill. If you got the skill down, you're great. Again, I told you it's 50-50 if you can just look at it and tell me. And again, this is not all your problems. We had 15 lessons. It's 50-50 if you can just look at this and say, hey, it's exponential, it's logarithmic. What do you think this time?
Logarithmic.
This is logarithmic. Why is it logarithmic?
Adding by 3 and x.
Not close. You said it's adding by 3. It's not actually adding by 3, it's adding by 2. Okay, what is that adding by 2 if it's in the y column? Do you remember? That is, whoops, I wrote A. That is your A. That's the nice thing about the logarithm is we now know if it follows this log base, because of properties, I cannot change this x minus h. You have to have that x minus h in there. What I can state right away though, is we now know our A is 2. A is 2. Let me write the word log. Okay, come over here. Is this just a straight up multiplication like our first logarithm where it went 1, 3, 9, 27? Is this a pretty little multiplication? No. So what should we do if it's not? Add a column, and what do we call this column that we're adding? The change of x. All right. How much does it change going from 3 to 5? And how much from 5 to 9? Or how much from 9 to 17? 8. How much from 17 to 33? 16. What's happening on all of those? So that means our, what does that tell us? Our base is 2. We now know this is a 2. Okay, so what I do on logarithms, I think this is the easiest way to do it, is because x's come before all transformations. Remember, when you look in, you start from inside out. The x values themselves come before any other transformation. What's easiest to do is to make sure that this is the initial point of our, if you're doing a logarithm, I'm talking about a logarithm now. If it's exponential, I would do it the way I showed you. If it's a logarithm, to make sure this is your initial value, meaning like your asymptote. I think the easiest way is to find the asymptote here. Now you might be going, well, how do I know it's the asymptote? Here's how you know. What's happening every time on the change of x? It's multiplying by 2. Now, is that the first power of 2? Meaning, is it the point? Remember how it goes b to the n, comma n? Is that this value right here, b to the 0, 2 to the 0? Is that equal 2 to the 0? No, that's 2 to the first. What I mean by that is there's another point in here we could add to our table. I'm going to add a point. Now, I know I can add a point because this is changing by 2. I should have a point where I have 2 to the 0, comma 0. Now, what is 2 to the 0? I need to have one that says change of 1. So what number plus 1 equals 3? 2 goes there. And these are always adding 2. So what number plus 2 would equal 5? 3. That's your initial value that we're going off of here. This is actually the initial value. All that to say, our transformations we could figure out from this one here. You could do it that way. Or if that confuses you, here's one more way. Again, x's are before the transformations. This takes away the transformation right here. What's the difference between these values? These are always 1 greater. So if you took 1 away from the x's, you'd have your change of x column. That's another way of doing it. Just saying these are 1. You see how it's 1 greater? If I took away 1, I get the change of x that I need for my logarithm. So that value right there is what goes in for h. So what I want to do here is I'm going to put x minus 1. Now, how do I know that? Is because these are always 1 off. So you don't even have to find that point. I gave it to you, but if it's confusing, then don't worry about that. Just look at it and say, okay, I see what's going on here. This value, because I'm dealing with x's on logarithms, this is before the transformations, they were 1 off every single time. So I need to subtract 1 from this column to make it right. If I take away 1, I can find the logarithms. So we have all that. The only thing we're missing is our k. So how can you find the k? Well, let's just plug in, and we only have to plug in 1 point. I'll show you. 3, 5. Let's plug that in. 5 is our f of x. We know a is 2, so it's log 2. What's our x on this first problem? First point we're plugging in? 3 minus 1 plus k. Right now I'm solving this for k. I'm going to erase this. That's just going to be extra and confusing later on. So we don't need that. Okay, and we'll solve here. What is 3 minus 1? 2. So this is saying log 2 of 2. What is log of 2 of 2? 1. That value is 1. So this is 5 equals 2 times 1 plus k. What is 2 times 1? 2. So 5 equals 2 plus k. You probably know what k is. How do we get our k there? Subtract 2. What are y'all getting? Are you getting 3? That's going to be our solution here. Our value is going to end up being a 3. So now come back up here, erase that k, and I'll put it as a 3. That is our equation. Whoops, I covered up the base. Try that again. So a logarithm, you don't have to use 2 equations if you can get the data from over here, but you have to mess around with it a little bit. What's nice about a logarithm is you can discover a from the change of y's. You can discover your horizontal translation looking at these values as well. Okay, how are we doing? You want to do more? Or you want to switch to something different? How many say switch? Got quite a few. Let's do a switch and then I'll come back at the end if you want to see more. How about that? Okay, yep. Go ahead. Without solving them, let's just write on the side. Let's just make it 50-50. What would this one be? Exponential, logarithmic? This would be exponential. How'd you know exponential? X's are adding, Y's certainly are not adding or subtracting. That's exponential. Okay, what about this one? Logarithmic. All right, picking up on this problem earlier, we said it was exponential. Why did we say it was exponential? What did we see that made it exponential? Easiest way is the x is only increasing additively. Once you come to your final AP exam, like the one that really counts, I want to remind you that there could be other functions based in, and so you would have to check the y column to make sure they're being multiplied. What are we adding by over here each time? Ones. We're adding by ones every time. Does that mean that's going to be a?
Yeah. No.
Very good. It's not a. Why is it not necessarily a?
It's exponential.
Because this is the x value. A is always dealing with which value? Y. Here's what I want you to write. If you're writing an equation for exponential all year, doesn't matter. This is going to be your general form that we'll solve for. It's going to be a times b to the power of x plus k. You do not have to do a horizontal translation, meaning an h, an x minus h, x plus h, because with exponentials, a horizontal translation is equivalent to a vertical dilation. I think it's easier to solve with just one fewer variable. So what you're not gonna see me do is this. When we're writing an equation, you won't see me do an h value here. You know how x's usually lie. I'm not gonna do it there because you could just solve. It'd be easier, in my opinion, to drop the variable and just make the A value be different, because a horizontal translation is equal to a vertical dilation. We learned that with exponentials. Meaning we could do our properties and just change A. So I'm gonna work through solving this. Let's begin with, is this problem easy to tell what's happening every time? No, so what did we do on the previous problems, table problems, to help us figure out what's it actually being multiplied? We did a change of Y column. I'm gonna do that now. So new row here, I'll call it change of Y. And so to go from 29 to 13. What happens there? So I hear minus 13, minus 16, I agree with that. Okay, what about 13 to 5? Minus 8. What about 5 to 1? Minus 4, 1 to negative 1. Minus 2, finally, negative 1 to negative 2. Minus 1. Okay, there it is. So what's our base? The base is the thing we're multiplying by each time to get from one number to the next. Now you can actually determine what are you multiplying by to get from negative 16 to negative 8 to negative 4 to negative 2 to negative 1. 1/2.
2.
Okay, if we multiply by negative 2, a negative 16 becomes a positive 32. So that actually wouldn't work. Would it be just 2? Negative 16 times 2 would be negative 32. So you're going the wrong way. You'd be going from the top or the bottom to the top, multiplying by 2. So what's the reciprocal of multiplying by 2? So you're going the opposite direction. 1/2. Here, what we're actually multiplying by each time is 1/2. We are multiplying by 1/2. That's what's happening every single time here. Is the numbers getting cut in half. So what does that find for us right there?
A.
It's the base. The base is the value, no matter if it's a logarithm or exponential. The base is the one that's doing the multiplying. So what letter is base?
B.
B. So how do we find our A and our K? We're gonna plug in 2 points to solve. So I'm gonna take my equation. And we're gonna say g of x equals, do we know A yet? We don't know A. Do we know our B? What's our B? 1/2 to the power of x plus. Okay, we're gonna plug in 2 points to this. And we'll use the 2 points to solve. Examine your table. Which points do you think are the best numbers to work with? We can pick any of them. They all should give us the same answer. I hear 2 and 1. Let's choose 2 and 1. I like 2 and 1. So 1's the y, 2's the x. So we have 1 equals a times 1/2 to the power of 2 plus k. And now let's simplify that. 1/2 squared, that means 1/2 times 1/2. It's gonna be 1/4, very good. I'm gonna write that in front of the a. So since it's a times 1/4, I'm gonna just say 1/4 a plus. Okay, you good with that? Okay, we're gonna pause and pick a different point. What other point would y'all like to use here?
1/5.
1/5? So 1's the x, 5's the y. 5 equals a times, oops, that's 1/2, sorry. What was my x? I already forgot. 1
Well, yes.
plus, okay. Now let's simplify that. What's 1/2 to the first?
1/2.
1/2, and so I'll just reorder it. So we have 5 equals 1/2 a plus. Okay, do y'all remember what we did from here? We subtracted. Okay, I'm gonna take. So looking at the 2 purple equations, I'm gonna subtract this one from this one. The reason I'm doing that is because I like working with positives, and I'm just looking at the 1 and the 5. Which one's bigger, 1 or 5? 5. I'm gonna subtract the equation that starts with a 1. So we're gonna subtract 1 equals 1/4 a plus k. So what do we get? What's 5 minus 1?
4.
4. All right, I need you to think here. You have half of an A and you're subtracting a fourth of an A. We could get a common denominator, but if you think of money, this will work. Half is like 50 cents, a fourth is like 25 cents. If you have 50 cents and you lose a quarter, how much are you left over with? A fourth. So 4 equals 1/4 A. What happens to the case? They cancel. That's the whole point of us doing that. And so now how do I get A isolated there?
Divide.
Multiply by the reciprocal, which would be 4/1, or we could just say multiply by 4. And so the 1/4 and the 4 cancel. And so A equals 16. Very good. So how could we solve the problem now? Plug it in. Do you want to use the first purple or the second?
First.
First. So we'll take that now. I'll plug it in right here. So 1 equals 1/4. What are we going to do? Instead of A, we're going to place 16 plus K. What is 1/4 times 16? 4. Very good. So 1 equals 4 plus K. How do we solve that? Subtract 4, and we'll have our answer here. -3 equals K. So our final answer, if I go plug in all the values, we have A, we have K, we have our B. We can now write the equation that G of X will equal, what do we say A was? 16 times 1/2 power of X minus 3. Sorry, getting that all typed in there. That would be our final answer right there. We put it all together. That's kind of a bad spot. I don't know why I wrote it there. Let me write it where it's not with the rest of the stuff. That's our answer. All right, questions on this one before I move on? So on exponentials, they do not give you A, but you only have to solve for 2 variables. And so we just plug them in like this. Now on logarithms, they will give you A, but you still have to solve for 2 different variables. So either way, you're solving for 2 variables when you do this, once you move beyond the table. Okay, questions on this one? All right. We also just quickly took a glance at this one last class. Y'all told me it was logarithmic. What did you see last class that told you logarithmic? The y's were adding? What did you say, adding? Subtracting. I would say they're subtracting by 1. These are subtracting by 1. Which I'm going to come back and ask a question about this. What's happening with the x's? It's hard to tell, but is it adding the same amount every time? 3 to 15 is adding 12. Do I add 12 to get from 15 to 40 to 63? So if I'm not adding, what must be going on? It must be multiplying. So we call this log. Do you remember what this consistent value on the y's is called? That is your A. A equals -1. So if we're writing a logarithm, it follows this form. A log B x minus h plus k. Well, we already found the A. We've already found the A. The A is -1. The change of y, that is your A. Now let's find the base. Can y'all tell what you were multiplying by right now? No, I can't. So let's do, how do we figure it out? Let's do a change of x column and it'll help us out. If I did a delta x, okay, what do I change going from 3 to 15? I already told you once. We're adding 12. How much do we go from 15 to 63? So 63 minus 15 is 48. Very good. 48. What about 63 to 225? 255, I'm sorry. Let's do a little subtraction. Visualize this. What's 5 minus 3?
2.
2. What's this 5 minus 6? Or 25 minus 6? Let's say 25 minus 6. It'll be 19. So that's 192 it's adding. And if I did it one more time, what's 23 minus 5? 18. So that gets dropped by 1. And so I think I'm getting off. I think it's gonna be 768. 768, 18, drop 50. Yes, I agree with that. 768, good. Good. All right, what's happening this time? Multiplying by 4. Since I'm multiplying by 4, what do we call that value? That's all the value that always multiplies. What is that always going to be? Your base. Since we're multiplying by 4, we would say that is the base. So our base equals 4. So the equation we're going to solve is going to be, if I plug that in, I'm actually going to give you the h really quickly in a moment.
Miss you.
The h is easier to solve in a log, but at this stage, I'm going to move over and say that we have f of x equals, what's our a? -1, so I'll just say negative log. What's our base? 4x, I'm going to leave a blank there, plus k. Now, how can you find your h? Now that you know you're multiplying by 4, here's the easiest way to find h. We have to multiply by 4 to go from 3 to 15, and 15 to 63. But does it work out perfectly? If you multiply 3 by 4 right now, does it give you 15?
No.
Gives you 12. So you could add or subtract the number to make it work right. We want these to be, when they're multiplying by 4, what number, whether it's a little bit less than, a little bit, if we added all or subtracted from all, would make this where they're perfectly being multiplied by 4. Anybody tell? Like what would get you to factors 4? 3 is not a factor of 4. What if we added 1? If you added 1 all the way across, what would this 3 become? A 4. What would this become? 16. Can 4 be multiplied into 16? Then if I added 1 there, could 4 be multiplied into 64? Would that work? You see how they're 1 off? This whole column needs to be added by 1. It needs to be x plus 1. If I added 1 all the way down, what happened to me? If I added 1 all the way down, okay, it's not that. I didn't put writing on. If I added 1 all the way down, would the columns now be multiplying with each other very well? Would they all be able to be multiplied by 4?
Yes.
Yes. So that's what we're going to do here. It's going to be x plus 1.
Is that the only way to do it?
You can plug in 2 points just like we did before, but you're solving a logarithm, which for some requires a little more work. So what I'm going to do here is, I think it's a lot easier just to look at, it has to be multiples of 4. So really 4 to the 0 power is 1. So if you had a 1 in your list, that's fine. We don't. You could have a 1, you could have a 4, you could have a 16, you could have those numbers. And if you're looking at what adds or subtracts to get me to those powers of 4. So adding 1 made this one work, I made all of them work. Subtracting by 2, you could subtract by 2 here to get 1, which is okay value. But if you subtract 2 there, you get 13. That wouldn't work. That's why it's a plus 1. I don't know if that makes sense. Okay, so from there, there's only one thing left to do. I only have one variable. If I only have one variable, I only have to plug in 1 point. Which point do y'all want to plug in? 3, 1. And you're plugging in the real point, not the fake plus 1. We're plugging in 3, 1. So which one's the y? 1 equals, whoops, I meant to change colors. Sorry, let me try this again. 1 equals negative log base 4 of 3 plus 1 plus k. All right. What is 3 plus 1?
4.
4. So I'm looking at 1 equals negative log 4 of 4 plus k. What? A log of 4 of 4. 4 to what power is 4? 1. That's a 1. So I could just say 1 equals negative 1 plus k. All right, Ruby, last step. What would we do from here? What'd you say? What would we do here? I'll open it up. How do we solve for k here?
Plus 1.
Just add 1. And so what is k? 2 equals k. By the way, I didn't write that up here. I should have said here, let me go red. That h is gonna equal, technically h is -1 because it's a lie. What we needed to do was add 1, so technically h is a -1. But whatever we made the table work, that's what goes in the equation. So technically we'd say h is -1, but because it's a liar. What you do over here is actually a liar. All right, oh, let's write the final equation. So we now would say that is this f of x? Yeah, f of x equals negative log base 4 x plus 1 plus 2. That would be our final equation right there. There it is. All right, any questions over tables?